Hi, welcome to the first video in Physics 211. Okay, so what you're seeing here is the sample of a snapshot of your course syllabus. So the goal for this course is order for you to gain ability to apply knowledge of mathematics and sciences to solve complex engineering problems. Okay, bibigyan ko ng disclaimer ha, complex, okay? But do not expect do not have a high expectation about the subject because we only have 10 weeks to complete. Okay, and second one is to in order for you to gain the ability to develop and conduct appropriate experimentation, analyze and interpret data. Okay, so interestingly this is like EDA. No, so you're going to do experimentation, analyze and interpret data, but I'll do my best to teach you the most essential as much as I can. Okay, so of course the requirements for this course in order for you to pass is you need to complete your assignment, quiz, major exams, and that includes the midterm and final examination. So for your learning, I am heavily relying on YouTube. So I'm making videos kasi you will never really understand the content of physics if you were just going to read it, okay? Because physics in its essence is this is a alive or this is alive or buhay na subjecto. You have to have your imagination and you have to have your visuals, okay? So you can't really survive physics without without the not without drawings, without illustrations like this. You can't. Okay, so for week one, for today's video, I'm going to show you introduction about the physics. I'm going to tell you what physics is all about in the concept on the perspective of physics, and then we're going to talk about kinematics, a little bit of kinematics, and then concepts and displacement, velocity, acceleration versus time graphs. Okay, so expect in this course, and expect in this video that you can, after the end of this video, you can analyze quantities that describe motions of particles, and you can analyze and solve kinematic problems with constant acceleration. All right, so let's go. So physics is okay. Physics. So physics is again, as I mentioned, is actually a science that deals with a lot of things, mostly more about phenomena in the physical world. Kaya siguro nanggaling yung physics sa physical, no? Tapos siguro physical plus ako, no, siguro. Oh yeah. Joke lang. Madadaan-daan lang. Joke lang, hindi. Nag-imagine lang ako. So, it's more about the physical world, really. So, when we see the physical world, this is all about the things that we can see. So, initially, there are a lot of renowned scientists who were very famous in the field of physics, like Isaac Newton. No? We have Galilei, and many other scientists in the field of science. So what they have in mind is that they only they only interpret what they see, but they only interpret what they see. Like for example, Isaac Newton noticed that there is a tree and there is an apple falling. Okay, so he just noticed that you know apples or objects do tend to fall to the ground due to due to gravity as we know it. But back then, the concept of gravity back then is not really it's not concrete. Okay, it's not concrete because who the hell can see gravity? We don't see gravity. So that is why physicists like Isaac Newton tend to describe. They only describe what's happening. So he is basically making a description of the phenomena. So a phenomena is anything. Define na lang natin. What is a phenomena, by the way? What is a phenomena? So a phenomena is a fact or situation that is observed, okay? Observed, okay? So when we say observe, you can see it, you can feel it, you can hear it, and you can taste it and touch, So you can use the senses to observe. To exist or happen, especially one whose cause or explanation is in question. So, alright, so this is a phenomena back then. So why do objects fall to the ground and not upwards? Okay, so those are just phenomena back then that of course they already understood and answered. So that is why Isaac Newton will already have the three laws of motion. So yeah, so that's it. So again, it's a physical world wherein you are going to interpret what's happening in the world. Okay? So that's the so let's go to the concepts. So as for the concepts, the most important thing that you have to understand about physics is the concept of time, distance, displacement, velocity, acceleration. These are the primary concept that you have to understand. Now, self-explanatory, time what makes an object valid in a particular time and space. Okay, what I'm trying to say is time gives you the existence. Okay, you exist in a particular because I said this because with time, uh, time can give you the sense of existence. You know why existence? Because you can only exist in one place at a time. You cannot exist at 2 points at the same time. So time gives you the sense of existence. So without time, you don't exist, basically. Okay. How about distance? Now distance is like this. I mean, the air or the distance traveled by my pen. Okay, so that's distance. Let's say house to school. You know, that's a distance. Okay, so we're good with time. We're good with distance. Okay. By the way, in time, we most of the time use the units for time in seconds. Okay, we most of the time use seconds, sometimes hours. Depends on the question, really. Okay, so how about displacement? Okay, there is a huge difference between distance and displacement, but the simplest way to understand displacement is the displacement is the shortest. Okay, displacement is the shortest path. Okay, so you consider the origin and the final point. So the shortest path is always called the displacement. So kahit magpaikot-ikot ka pa yan, kahit magpa-banjing-banjing ka pa dito, the displacement between between your house and the school is this. Okay, but of course ito yung kalsada, but the displacement is this. So this is the shortest path. Now velocity. Okay, let's talk about velocity for now. So velocity is a is a description of how fast you're moving. Okay, so how fast you're moving. So this velocity is expressed in the formula v is equals to the change in time, change in distance or displacement. Sorry, displacement. Change in displacement over change in time. Okay. All right. So when we say velocity, it is like, um, okay. Let's talk about the concepts now. So we can have a positive and negative velocity. I'm sure you can agree with that. But again, as I said, velocity can be positive or negative. So, egal, paano nangyari po yun? Okay, remember your physics back then which talks about scalars and vectors. So review na lang. So scalars are quantities that does not give you any kind of direction, while a vector gives you a magnitude and a direction. So when we say scalar quantity are like, scalar quantity is like your mass, like kilogram or kilograms. So that's scalar. How about vector? Vector is has a magnitude and a direction. So this is like velocity, because you have a a magnitude which is kilometer per second, and then you have a direction which is, for example, due to east, or due to north, or due to south, or due to west. So you have a direction. So so that's a difference between velocity and speed, because scalar quantity is speed, okay, and vector quantity is velocity. Because in speed, you don't really care where are you going. Velocity cares where you are going. Okay? So, sir, bakit hindi natin ginagamit yung speed? We use velocity because we are dealing with the direction of a particle. Okay? Because, okay, because in speed, you can only get an idea how fast the object is moving. But with velocity, you can know what direction, where is the direction of the particle going. Again, as I already mentioned, physics is explaining the phenomena. So, you have to understand that objects can either go upward, can go downward, can go sideways. So, if this is a three-dimensional, so you're considering another variable or another factor, which is z. So, what I'm saying is, an object moves. Okay? Purahin ko na lang. What I'm saying is an object, and when you have an object rolling on the floor, the object can either move to the right or to the left. So the object with the speed, let's say the speed of the object is a particular x meter per second. So you have a speed and you have a direction, because that's how you describe it. You don't just describe, okay, the ball moves with 5 meters per second. Okay, so the question is, in what direction? Is it going upward? Is it going upward? Obviously, it cannot go upward. Is it going downward? Or is it going to the left? Or is it going to the right? So, so between the two, between between speed, so between speed and velocity, velocity is far more, has more information than the former. Okay, so we use velocity. Now going back here, so how come, sir, that velocity can be positive or negative? Okay, how come, sir, that velocity can be positive or negative? As I mentioned, velocity is a quantity, is a vector quantity, so it has a magnitude and direction. Now, what I'm going to show you is the concept of reference point. Sir, what's reference point? Okay, so I'm glad I asked. So reference point is like this. So let's say you're standing. Let's say you're standing here. Okay, at this point. This point. And then you said, okay, I'm going to move 5 steps to the right. Okay? So, let's say nandito na siya. So, it's already 5 steps. So, this is the original point. Okay? So, this is the original point. And this is where you are right now, 5 steps. And then you decided, okay, I want to go back. I want to go to the left 7 steps. So, when you go 7 steps, you are already here. So, this is the initial point, 0. So, this is the previous point, 5. Okay, so you go 7 steps. So, you're here. And you are negative 2. Sir, negative 2? Yeah, because the reference point is at the very initial point. So, this is where you started. And again, as I already mentioned, we are talking about displacement and not, okay, we're talking about displacement, not distance. But if we're going to talk about distance, obviously this is a 7 step. Okay, so when we talk about distance, we have 7 steps, right, from this point. But if we talk about, yeah, if we talk about this point, we have 2 steps. We don't care if it's negative or positive. We're just saying it's at a distance, right? So the displacement from the original point and to the first, this is the point A, this is point B, this is point C. So from A to B, you have a 5. You have a positive 5. And from point B to point C, you have negative. You considering A, from point A to C, you have negative 2. Because overall, the displacement that you have is only 2. Now, it is negative because you're already considering here. So you did plus 5 movement to the right. Obviously, if you're going to the left, okay, that will give you a negative 2. So that's the concept. I hope you are getting the idea. Now, let's go back. Now, that's the reference point. So the reference point here can tell you exactly what to interpret. So if the reference point is this one, your displacement is negative 2, and if this is your reference point, this is your next point, and this is obviously plus 5. But if this is your reference point, okay, if you put your reference point here and look at this, you have negative 7. Okay, so you have negative 7. Sir, why? Because we are saying here that every movement to the left is negative and every movement to the right is positive. Okay, so ibig sabihin, kapag dito ka magre-reference point, your displacement here is already negative 7 because you're already saying that you are moving negative 7 steps to the left. Okay? Kasi diba nag 7 step ka? Diba ito nga, no, negative 7. Alright? So, that's the idea of reference point. So, velocity can be positive or negative if you're going to think of that. Because, as I mentioned, okay, velocity is the change in displacement in time. Right? And I said, displacement can be positive or negative. So, ibig sabihin, kapag negative 7 yung displacement mo, and you have time, let's say 2, then you have a negative side. Okay? So, okay, what I'm saying to you is mathematically speaking. So, we don't use this in our everyday life. Okay? This is just mathematically speaking. Kasi, we cannot say, I have a velocity, negative 20 velocity. Okay, you don't really say that, but mathematically speaking, you say that because that is the right way to say it. That is the correct way to say it. Okay, so velocity can be positive or negative or zero, of course. Or this can be zero. When you say velocity is zero, then obviously the particle is not moving. Okay. Now we go to acceleration. All right, acceleration. Acceleration is how the increase in speed in velocity. Okay, this is okay. So acceleration is the increase in speed in velocity. Okay, but for the sake of this course, we only assuming that the acceleration is constant. Okay, it means it's not changing. So again, as I said, acceleration is the increase in speed, the increase in velocity. Okay, so it's like, for example, a particle from as high as this, and then this is the ground. Let's say this is the ground. So an object will slowly increase. Ganon. Okay? So, biglang bibilis yan eh. Ibig sabihin kasi, you are experiencing gravity here, and that gravity is also equivalent to acceleration, and that is fixed 9.81 meter per second squared. Okay, so that's the unit for acceleration, second squared. So because if you're going to digest this really, Acceleration is change in velocity over change in time. And we already know that velocity is meter per second. So, meter per second is meter per second squared. Okay? So, diyan ko nasabi na acceleration is the increase is an increasing velocity. Okay? It's increasing velocity because you are increasing your velocity constantly. So, yeah, you're increasing your velocity constantly. So, the easiest explanation for this one or example is how you drive your motorcycle. Okay, motorcycle. Patawad na lang sa motorcycle, hindi ako marunong mag-drawing dito. Okay? So, alam niyo naman yung silinyador, di ba? Yung accelerator. So, pipigayin niyo yung accelerator, biglang bibilis. Okay? Tapos, bigla niyong tatanggalin yung accelerator. Pag binitawan niyo yung silinyador, tatakbo kayo pero mabagal. So, that is a constant velocity. Okay? So, imagine niyo na lang kapag nag-drive kayo yung motor. Kapag piniga yung accelerator, pag piniga niyo yung accelerator, boom, bibilis. Kapag hindi niyo piniga ang accelerator, pag hindi niyo piniga ang accelerator, tatakbo pa rin siya pero constant lang ang V. Alright? So, I hope you get, I hope may gets kayo dyan. So, i-explain ko lang in mathematical aspect. Okay? So, just like any other vector quantity, acceleration can also be a positive or negative one. So, acceleration can be positive or negative or zero. Okay? So, this is interesting. When you have a zero acceleration, it doesn't really mean that the velocity is zero. So, remember that. Always remember. Okay? Because the velocity can still move even if you have a zero acceleration. Kasi again, gaya na sinabi ko sa kanina, sa silinyador, kapag hindi nyo piniga yung accelerator nyo, yung motor nyo tatakbo pa rin. Okay? So, parang ganun lang yung concept. So, okay, so let's go to the displacement, velocity, acceleration versus time graphs. Okay, so what I'm going to show you here is the graph. Okay? Okay. So this is the velocity versus time graph. This is the distance versus time. This is the velocity versus time. And this is the acceleration versus time. Now, since we are calculus based, I'll do my best to teach you how to interpret this. Now, first recall your analytic geometry. Okay? So, if you're going to recall your analytic geometry, we have point slope form, we have slope form, we have the equation of the line. So, remember the formula y is equals to mx plus b, and where m is equals to delta y over delta x. Okay? So, those are the two things that you have to understand about analytic geometry. Now, let's focus on slope. Okay, so let's, for example, this is your x and y axis. Okay, and let's say you have this point, and then you have this another point. Okay, and you have this line. Then, di pa actually line yan eh, points lang yan eh. So, you have this line. Then, okay. So, this line has an equation y is equals to mx plus b. So, remember your EDA. So, parang binigay ko sa EDA sa inyo to, di ba? Yung y is equals to mx plus b. Okay? So, pero dito sa analytic geometry, particularly physics, you're only going to focus more about the slope, which is m. Okay? Okay, m. Okay. Hold lang muna tayo dyan. As I said back a while ago, velocity is the change in displacement over change in time. While acceleration is the change in velocity, change in time. So, do you see the similarity between the three? There is a slope. This means that velocity is a slope of displacement over time, and acceleration is the slope of velocity versus time. Okay? Okay? All right. Now, what if we replace these variables? And so we have velocity here, okay? And we have time on the x-axis. So we have time. And we have, let's say, distance, or displacement, sorry, displacement. Okay, so set na lang muna natin ha. Displacement equals letter S. Okay? So letter S tayo. So S. So let's say this is your particle. Let's say initially na lang from the origin. Okay? So I'll let you imagine this scenario. Okay. So at 0, 0, it means that you are not moving. You have a 0 displacement and you have 0 time at particular time. Okay? So let's say dito ikaw. Yan. Trying natin ha. So let's say ikaw yan. Okay. At dito, initial time 0. So displacement mo is 0, right? So hindi ka pa umalis. So let's say you stepped 5 at, let's say, 2 seconds. Okay? So you're already here. So it means at after 2 seconds, this is your initial point. You're right now here at 5 steps at 2 seconds. So let's say 5 meters. This is let's say 5 meters. No. So how do we interpret that? How do we translate that to the displacement versus time graph? Okay, so this is your first step. Kasi wala ka pa talagang displacement, you have 0, and then you move 5 positive. Okay? So let's say 5. So this is let's say this is 1, this is 5, and this is 10, and this is 20, 15. Okay? And let's say after 2 seconds, this is where you are right now. Okay? So this is your line. This is your line. This is your motion. This is your motion line. Okay? That's your motion line. Now, how can we get the slope of this line? M. And of course, that slope is equal to the velocity, right? So, we're going to use this formula. So, let's say M, okay, is equals to V, is equals to, the slope is equals to velocity, and velocity is equals to the change in Y. Okay, so change in Y is the initial versus final, so we have final minus initial, 5 minus 0, and then we have 2 minus 0. So we have 5 over 2. And that's 5 over 2 meters per second. So that's your velocity. Okay? So how about, sir, right, for example, sir, we have a third scenario. Let's say, sir, that medyo tinamad ako. Siguro nag-chat muna ako sa bebe ko. Nag-chat muna ako sa bebe ko, sir. Di ba nandyan ako sa 5 meters and then 0. Let's say, sir, na nag-extend ako, sir, kasi na parang gusto ko muna mag-chat sa bebe ko. Tumagal ako dyan, sir, ng 5 seconds. Okay, ulitin ko lang, ha. Di ba dito ka dati? Then sinabi mo maglalakad muna ako ng 5 meters, then after 2 seconds, nandito ka na. And then you realize na, wait lang, chat lang ako sa bebe ko. No. Chat lang ako sa bebe ko. Then, nagstay ka doon ng 5 seconds. Now, how do you put that into your motion graph? So, let's say, okay, bago natin yung kulay natin. Gawin natin orange. So, ang mangyayari dyan, you did not move at all, and you increased 5 seconds. Tadan! Okay? So, gets nyo? You did not move at all. So, again, this is the displacement. You remain at your initial point, so you have 0 displacement. And you have, okay? You have 5 here. And you have another 5 here. Sorry, you have 2. And you have 5 here. So, obviously, you have 7. So, this is not 5. This is already 7. And this is 2 seconds. So, this is your 2 seconds. This is you at 2 seconds. This is you at 2 seconds, and this is you for another 5 seconds. So, this is you. So, this is your motion graph. Okay? So, again, ano ba ang slope dyan? Sir, wala pong slope yan kasi straight line yan. Obviously, 0. So, ibig sabihin, ang velocity mo, 0. You did not move. Obviously, you have a 0 velocity. Diba? Alright? So, how about let's give you another scenario for the fourth scenario. Okay. Let's say that you have a fourth scenario, you try to okay, how about I go back to the previous point. So, you decided to go back to your initial point. You decided to go home. So, let's say this is where you are right now, 5, and you decided oh yeah, so how about I decided to move. How about I go back to where I came from. So, this is where you are before, and this is where you are now. So, again, you move to the left. So, obviously, you have a negative direction, implies that you're going to the negative displacement, so 5. So, you are here right now at 0. So, you have a 0 displacement because you came back to where you came from. But, you move, okay? But you move, right? So, let's say that you move at exactly 1 second. Wow, ang bilis Alright, so 1 second. So, how do you translate that to your motion graph? So, gamit tayo ng kulay. Gamit tayo ng, let's say, yellow. Okay? So, how do you translate that to your motion graph? Okay. So, sir, in displacement, sir, di ba, 5 pa rin kasi yun yung tinakbo niya dito 5, oh. Okay, so, dito ka. And then, sabi mo, pabalik ka. So, at 1 second. So, shook. So, dumagdag ka lang ng 1. So, ibig sabihin, 8 yan. So, this is now your motion graph. So, again, if we're going to recall your analytic geometry, alright? So, this kind of line has a slope which is positive, and lines which has like this of negative slope. Tama? Tama? So, ganun din yung dito. So, this is your complete motion graph right now for the first instance. Okay, wait lang. This is for your motion graph for the first scenario, second scenario, third scenario, and the fourth scenario. So the first scenario is that you are in the origin. Second is that you move, okay, and then here. So how about the slope for this one? Obviously, the slope is equivalent to what is your displacement? You have a negative displacement, which is a negative 5 divided by time 1 second. So you have a negative 5 meter per second. Okay? Okay, so wait lang. Takyan ko lang konti. So you have a negative 5 meters per second. Okay, highlight lang natin. 5 meters per second versus, since original kanina, 5 over 2. Ano mas malaki? 5 over 2 or 5? Obviously 5. So that is the meaning behind the slopes. So when you see a slanting lang, mababa lang ang slope niyan, ibig sabihin mababa ang magnitude niyan. But you see a very high slope, mataas din yung magnitude syempre. Okay, so ibig sabihin mabilis. Dito, ito, mas mabilis ka kaysa dito. Ito, hindi ka talaga mabilis at all kasi di ka gumalaw. Okay? So, take note, class, this is just for velocity. This is just for the velocity. Okay? So, sir, how about for acceleration? Okay, so another example. As I said, acceleration can, for the sake of this course, you only have a constant acceleration. Okay? Okay, constant acceleration. Okay, so for now, we're going to introduce the concept of acceleration time graph. So we have acceleration here, and we have a, oh wait lang, di pa pala. Velocity versus time graph pa pala. Okay, velocity versus time. Right. So kanina kasi displacement versus time yon. So now that we are talking about velocity versus time, we are talking about acceleration because this is the change in velocity versus change in time. Okay? So let's try to give another example. So let's say you're driving a motorcycle. You're driving your motorcycle again. Hilig mo mag-drive, no? Wait lang, parang ganyan. Okay, so let's try yan, motor. Yan, yo, yeah. So, yan. Ano naman yan, bala yan. Okay. So, let's say tumatakbo ka na, no? So, let's say na tumatakbo ka na, ha? Hindi ka stationary, ha. Let's say tumatakbo ka na, ang nasa speedometer mo, okay. Let's say nasa speedometer mo ay 40, no? 40. Okay. Now, what you see in your speedometer is what we call instantaneous velocity. Yun yung instantaneous velocity mo. Okay? So, let's say 40. Okay, sir. May 40 na agad. Hindi tayo magsa-start sa 0. Okay, right. Alright. Oh, wait lang. Mali. At time 0, dito tayo magsisimula. Hindi tayo sa origin. Kasi meron tayong 40. Okay? Sir, ganyan ba talaga, sir? Dapat? Diba dapat nandito yon? Hindi. Kasi, ibig sabihin may time na. Ay, wala. Wala naman eh. Sinabi ko lang na instantaneously, ito yung acceleration niya. Ito yung velocity niya, 40. Okay? And then, let's say after 10 seconds. Okay? Ito yung original point mo, no? Let's say after 10 seconds. After 10 seconds, dito na yung motor. Okay? Alright. Then, napansin mo, uy, yung velocity ko bumilis. So, naging ano na ako? Naging 60 meters per second. Okay? So, after 10 seconds here, velocity mo ay naging 60 na. And, yan. Okay? So, ibig sabihin, bumilis ka. Okay? So, ibig sabihin, pinihit mo yung silinyador mo dito. Pinihit mo yung silinyador mo, kaya bumilis ka. So, dahil pinilit mo ang silinyador mo, obviously, ang acceleration mo ay merong value yan. Hindi yan 0. Tama? Okay. So, compute natin yung acceleration. So, ilan ba yung acceleration yung pinihit mo yung silinyador mo? So, of course, that is A is equals to change in velocity over change in time. Tama? So, that is 0, 40 minus 0, divided by 10 minus 0. So, that's 4 meters per second squared. So, you have an acceleration here or slope. It's equals to 4 meters per second squared. Okay, so that's the first scenario. So, how about I give you another scenario? How about another scenario? So, let's say, habaan ko na ng konti. Nakatakbo yan eh. 0. Okay, yan ang initial point mo at point A. Then point B. 10 seconds. Okay? Dito ka na kanina. Okay? And then ngayon, dito ka na. Let's say point C. Point C natin, let's say, is after 20 seconds. Okay? After 20 seconds, let's say na, okay, ang velocity ko, sir, ay 60 pa rin. Wow, 60 pa rin. Okay? 60 pa rin. Tama. So, how do we translate that to the time of velocity versus time graph? Okay, so, ganito. Gamitin yung kulay orange, ay yellow na lang. So, you are currently here at this point B. And then you said, after 20 seconds ay 60 pa rin. Okay, 60. Okay. So, ito yung line mo. Straight line. M is equals to 0. Then, A is equals to 0. So, ibig sabihin, hindi mo pinit yung cylinder mo. Dire-diretso ka lang. You are ibig ko sabihin is hindi mo binago yung cylinder mo. So, you only maintained your acceleration. So, when we say maintained, it's constant. And when it's constant, acceleration is 0. So, straight line. Yan. Alright? So, that's how you put into perspective the motion time graphs and then the velocity time graph. Now, okay, so i-level up natin. As we already mentioned before, acceleration and velocity is the change in change in. So, it's a changing variable. So, when you say changing in variable, we're talking about differential or derivatives. Right? We're talking about differential derivatives. And we already know that the antiderivative is the integral or integration. Okay? So, integration. Derivatives is dx over dy, and integration is dy or dx. Right? Remember? Okay, so integral calculus na tayo ngayon. Now, let me simplify things a bit. So, we start from displacement. And then, if we're going to differentiate displacement with respect to time, we have velocity. And if we're going to differentiate velocity with respect to time, we have another one, which is acceleration. Okay? It means you can get the velocity. You can do the opposite. Okay? You can do the opposite. You can get the velocity if you have the acceleration. If you're going to integrate, and you can get the displacement using your velocity if you are going to integrate again. Sir, integrate? What are we going to integrate, sir? You're going to integrate the equation of the line. You're going to interpret the motion graph. Okay? So, okay, jump na tayo, no? So, I hope you get the concept, no? So, you can, if you have the displacement, you can get the velocity if you're going to differentiate displacement with time. You can get the acceleration if you're going to differentiate velocity with time. Okay? Now, you can get the acceleration, you can get the velocity if you're going to use acceleration, if you're going to integrate the formula of the motion graph. So, that's how you convert it. Okay? So, I'm going to find an example. Okay, so, going back. So, let's try to make a good explanation or example. No? Alright. So, again, so let's try to do this now, velocity to displacement. Okay. So let's say velocity here and you have time here. Oops. Okay, so let's say at 0, 0. No. Ganun pa rin. Parang mas maganda tong pen na to. Ayan, nice. Let's say at 0, 0 here. And then you decided, okay. So at 0, 0, this is your point. And then we have point B. Okay? Ang point B natin, let's say, ito. Itong pangit yata. Magkulay. So here, and then we have point B here. So we have point A. And we have point B. Okay? And this is the line that connects the 2 points. Okay, so we need to have the equation. Again, as I said, you can only do with the equation here because you're going to integrate or differentiate. So let's say that this is point A and this is point B, and you have point B here. Let's say that the velocity at the particular time, okay, let's say the particular time is 20 seconds and the velocity is that 40, oh wait lang, 40 na lang, parang di butal, 40 meters per second, okay? So you have 2 points. So we have point A, that's 0, 0. We have point B, we have 20, 40. Okay, now recall your analytic geometry. How can you create the equation of the line using 2 points? So you're going to use y or 2 point form. You're going to use 2 point form. So y minus y sub 1 is equals to the slope multiplied by the quantity x minus x sub 1. Okay, so 2 points. 2 points. Oh, tama, tama. Okay, so we're going to say that the initial one, let's say that the y sub 1 is 20 and x sub 1 is 20. Okay, so let x sub 1 is 20 and y sub 1 is equals to 40, and we're going to find the slope. Okay, so this is the initial and this is the final. Okay, so we're going to 0, 1. Okay, actually this is 0, no, not, this is not. Okay, when I say not initial, okay, that's initial, so 0. Okay, so initially 0. Okay, so y 0. Okay, but for the sake of this one, oh no, 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 not really. This is the standard equation pala. Okay na yan, walang mga not dyan, okay lang yan. So sa equation na tayo sa slope, so we have x sub 1 minus x sub 0. Sorry, baliktad pala. We have y sub 1 minus y sub 0, or y naught, and x sub 1 minus x naught. Okay, so the slope is equivalent to 40 over 20, and that's 2 meters per second. Okay, so we go back to the equation. So y minus y sub 1 natin is 40 equals to slope, which is 2 multiplied by x minus x sub 1. X sub 1 natin is 20. Right? So we have y minus 40 is equals to 2x minus 40. We have y is equals to 2x minus 40 plus 40. So y is equals to 2x 0. Okay, plus 0 or 0. So this is our equation. Y is equals to 2x. Now, how do we... Okay, so this is the velocity versus time. Again, going back here, if you're going to differentiate, if you're going to integrate velocity with respect to, of course, with respect to time, sorry, if you're going to integrate velocity, you will get the displacement. Okay, so let's try to integrate. No? Right. So, sir, paano i-integrate? O, taas na lang, wait lang. Okay, so integrate tayo dito. Okay, so integrate, gamit tayo ibang kulay, gamit tayo ng puti. Okay, so we're going to find the displacement, which is S. Because S is the, so S, okay. So, integral of v with respect to x from t initial t final. Okay, so that's a formula. Tuntay konti. Alright, so S is equals to, ang v natin, ang formula natin for v is 2x dx. Okay, fix lang yan, 2x yan, and then our initial time is 0 kasi balikan natin yung equation, yung motion graph natin, nag-start tayo sa 0, and then our final time is 20 because we have 20 seconds here, so this is the time final. Okay, this is 20. Therefore, S is equals to, if we're going to integrate this one, so we have 2 x 1 plus 1 over x 1 plus 1. Okay, so evaluate from 0 to 20. And we know, if you're going to recall if you're going to focus on your integral, the integration of this one is upper minus lower. So this is going to be the integral of this is going to be a upper minus a lower. Okay? So yung upper mo, upper mo ito yung lower mo. So this is equivalent to 2x squared over, sorry, hindi pala x yan, 2 pala yan. Then, nakakalimutan ko integral ko. So this is 1 plus 1. Okay? So we have 2, right? We have 2. Ulitin ko na lang nga para malinaw. Okay, ulit. Wait lang po. Okay. So, integral of 2x dx is equivalent to, okay, side note lang tayo dito. So, magiging 2x 1 plus 1 all over 1 plus 1. This is equivalent to 2. Tama. So, 2 cancel. We have x squared. Okay? So, you have x squared evaluated from 0 to 20. And again, as I said, upper minus lower. So, this is x. This is 20 squared minus 0 squared. So, this is 20 squared. So, 20 times 20, 0, 0, 0, 4. So, we have 400. So, the displacement is equals to 400 meters. So, this is the answer. So, sir, tama po ba? Yan po yung displacement. Well, yan yung yan yung haba na tinakbo ng particle mo. So, by its form o by its motion graph, ito yung motion graph mo eh. Ito yung motion graph mo. And then, using this motion graph, at 20 seconds, you're going to know how far did you go. Okay, so counter check natin. If we're going to counter check using kinematics formula. Okay, so for kinematics formula, of course, you go to Google. Okay, so sulat nyo na. Gumawa na kayo ng write-up nyo dito. Prepare. Okay. So this is your motion formulas. So we have V is equals to V initial plus AT. Okay. So we'll try to use number 1 formula. V, di pala V. Kasi displacement pala tayo, di ba? We're going to check for displacement. S. Okay. Ito. Pwede ito. Wala tayong acceleration pala. So, purely velocity. Velocity times time. Di ito. No. So, ito. Let's use this one. So, the displacement S is equals to velocity times time. Okay? So, ano yung velocity natin dito? So, the velocity is, not really. Acceleration pala makukuha natin dito. Okay, try natin kunin acceleration. Acceleration is equivalent to the 40 divided by, so that's 40 over 20. That's 2 meter per second squared. Tama? So, that's the acceleration. Now, we'll try to use, if we're going to find the area. We're going to find the displacement. I-check natin kasi displacement kasi nakuha natin eh. Let's try to find out if we're going to arrive to the same answer. So, review lang natin yung equations. The acceleration, ito. Ito. So, displacement is equals to V initial versus the time plus 1/2 AT squared. Okay. Now, looking at this scenario, our initial velocity is 0. So, time natin is 20. Tama? Ang 20 natin yung time. 20 yung time, 20 seconds. Plus 1/2 Ang ating acceleration is 2 meters per second. Ang time natin is 20 squared. Okay, so this is 0 already. This is cancel. So this is 20 squared. 20 squared. So, yeah. So we have 400 meters. So, tama. So, we are arriving at the same conclusion. So, we have the same conclusion using that kinematics formula. Okay, so class, you have to take note of these formulas. Susulat nyo na. Okay. And then, we arrive at the same displacement using the motion graphs. Okay. So, sir, bakit mo ginagawa yan? Ginagawa ko to kasi calculus-based tayo. So, I'm showing you how we are doing this in the sense of, in this perspective of calculus. We're not purely using formulas. So, that's the proof, that's the point I'm trying to make. Okay? Okay, now, you get the acceleration, we get the displacement 400 meters per second. So that's how you're going to do it. Now, the second one is you're going to look at this one. I'm going to give you an advanced tip here. So look at this. Look at this. Okay, so you have an area here. You have a triangle. Right? If you're going to remember your area of the triangle, that's 1/2 base times height. Right? Right? That's 1/2 base times height. Now, before I push that one, I'm going to give you an idea of how the area of the rectangle works, how the area of a square works. Okay? Area of a square. So that's length times width, right? Okay. Let's try this one. So, let's try to use this triangle. So, ano lang to advanced lang to para sa mga gusto mag-explore. So, we have a triangle dun sa graph. We have 20 here and we have 40. Tama? Oh, yeah. We have 40, we have 20. Okay? And I said, area is 1/2 base times height. So, we have 1/2. Base natin is 20. Ang ating height is 40. Okay? So, if you're going to look at this one, so 20 times 20, area is equals to 400. Tadan! So, okay, in essence, integrating is like, okay, in essence, integrating a curve gives the area under it. Okay? So if you're going to integrate a particular curve or line, you are getting the area under it. Okay? So ano na lang yan tip lang yan sa inyo. Baka kasi magtaka kayo sa integral calculus nyo. Bakit pa may kuha ng area under the curve? Okay, you're getting the area under curve because that's how you do it. Okay, so that's just simply saying that you can get a particular area by not simply using the formulas for area of a shape. So you can use integration. Now, magiging useful yung integration sa inyo kasi nga, obviously, ano ba naman problema ng mga pen ko? Kasi, ano ba yan? Kasi, ang dali lang kunin ng area ng mga ganitong shapes Square, triangle, rectangle, square. Ang dali lang kunin ng area ng mga yan. But, the question lies in how ba yan? How do you actually get the area of, how do you get this kind of area? Again, as I said, integrating the line under its, integrating the line gives you the area under its curve. Yan. You're getting the area of this. Yan. You're getting the area of that. Now, how do you get that area kung ganyan na may mga lubak-lubak? Diba? Yun yung point. Yun yung gustong sabihin sa inyo sa integral calculus. So actually, yun yung pinaka-essence ng integral calculus, how to get the area of a given curve or a curve, okay? So, okay, so I hope you get the point. That's the essence of the calculus-based physics. So right now, you already get the point of using displacement, velocity, acceleration, time graphs, that in order for you to arrive at the conclusions or solutions, you have to get the formula or the equation of the motion graph first, okay? Kaya yung kanina, you have to get the formula or equation of the motion graph before you can get before you proceed with the differentiation and integration, as well as you get the concept of the time, velocity, acceleration, and there are actually negative and positive. There are You assume that there are positive and negative velocity and acceleration, right? And when acceleration is 0, it means to say that the velocity is constant, right? Okay. So, okay. So now I'm going to leave you with these formulas that is being used in kinematics. Okay. So rewrite lang natin. So these are the kinematics formula or equation. So hindi na kayo hindi na kayo mag hindi na kayo gagawa ng mga parang integral dyan kasi ito na yung equation na derived dun sa mismong motion graphs. Okay? Na derive na ito doon. Now, but before I proceed with this one, baka kasi naitanong nyo, Sir, paano sir kukunin yung motion, paano kukunin sir yung sagot sir kapag ganito yung mga problem? May ganitong line, tapos may ganito, tapos may ganyan, tapos may ganyan, tapos may ganyan. Okay, so ang technique dito is use section 8. Okay, so this is section A, this is section B, this is section C, this is section D, and this is section E. So, ang sum mo niyan, ang sum is of course, total nyo lang. A plus B plus C plus D plus E. Now, I'm talking about the area under this. So, ibig sabihin, kapag velocity versus time yan, ang inyong sum, pag V versus time, ang sum nyo ay yung kanyang displacement. So, ano yung displacement ng object nyo? Okay? So, what if acceleration, hirap naman. Okay, what if acceleration versus time? Okay? So, the integral of the acceleration versus time, okay? So, displacement. If you're going to differentiate, you get velocity. And if you're going to differentiate this one again, you get acceleration. Now, going back, you're going to integrate, you get velocity, you get displacement if you're going to integrate. Okay? X dx, initial, time final, time initial, time final. Now again, if you're going to integrate acceleration, you get velocity. If you're going to integrate velocity, you get displacement. Now, here, looking at the motion graph here, if this is the motion graph, the sum of the area of the curves or the line is the velocity. Okay? So, I hope that's clear now. I hope that it can really help you a lot. And again, going to the equations here, the four kinematic formulas are as follows. Velocity final is equals to the V initial final or V naught plus acceleration versus time. And the displacement or delta x, or let's say S, diba? Displacement is the velocity final minus velocity initial divided by 2 times time. Okay, so this is assuming that acceleration is constant. Okay? So you're only going to use this formula if the acceleration is constant, okay? Kapag changing ang acceleration, you cannot use this formula. Again, another formula is the velocity initial times time plus 1/2 acceleration times squared, and we have the last equation, which is the final velocity squared is equals to the initial velocity squared plus 2 times acceleration multiplied by the displacement. Okay, so laro-laro lang yung formula na yan, makukuha niyo yung problem, but obviously, you have to interpret the problem first. So, I hope that's summarizes the topics. Okay, so overview ko lang kayo sa pet simulation. We're going to use pet simulation kapag nag-start na tayo sa mga motions. And, yeah, motions. So, this is the pet simulation. I hope na i-download nyo na sa PCs nyo. We also have this in our mobile phones. Anyways, I'm going to make videos for this one. Okay, so I hope that's clear now. Thank you for week 1. We're going to talk about week 2 dynamics next week. Okay, bye-bye.